Welcome to The Explainer. Today we're putting on our detective hats and diving deep into one of the most common mysteries in software development, the case of the slow query. The question that keeps developers up at night. You click a button and that little loading spinner just keeps spinning. Is it the network, the server? Is it my front-end code? It's a super frustrating mystery, but don't worry, today we're going to crack the case.
You know, more often than not, the performance bottleneck isn't some super complex logic in your application. Nope. The real culprit is usually hiding in plain sight, right inside your database. Specifically, it's all about how it finds the information you've asked for.
Okay, so let's get into it. To solve this mystery, every good detective needs a toolkit. And for slow queries, your number one tool, your secret weapon, is something called the Query Execution Plan. This is how we're going to get our first real lead. And that weapon is a super simple command. Explain. Think of it like a special X-ray magnifying glass. It lets you peer inside the mind of the database to see its exact step-by-step plan for fetching your data. And the best part is, you can do all of this without actually having to run the slow query. So you run it, and you get an output that looks something like this. Now, I know it looks a little intimidating, but this table is basically the database's confession. It's telling you its whole plan. And while there are a few clues here, like key being null and that huge number in the rows column, our prime suspect is hiding in that type column. And here it is, seeing type all for a table with millions of rows. That's the smoking gun right there. It means the database is doing a full table scan. It's literally reading every single row to find what it needs. What we want, our goal, is to see something efficient, like ref, which is a targeted lookup.
So, we've found the problem, a full table scan. But how do we actually fix it? Well, let me introduce you to the hero of our story, the database index. Let's take a look at how it saves the day.
This quote just nails it, doesn't it? A full table scan is exactly that. Reading an entire book from cover to cover. It's exhaustive, it's inefficient, and it's a huge waste of time if all you need is one little piece of information.
So the index is the solution, and it works just like the index at the back of a book. Instead of scanning every single page, you just look up the term, it gives you the page number, which is kind of like a direct pointer to the data's location, and you jump straight there. It's a total game changer.
And, behind the scenes, the magic for most indexes is this really clever data structure called a B tree. All you really need to know is that because it's always sorted and balanced, it lets the database find data incredibly fast. We're talking logarithmically fast. That means even if your table doubles in size, the search time barely even budges. It's pretty amazing.
But hey, this is a detective story, and every hero has a weakness, right? This incredible speed boost for reading data doesn't come for free. There's a hidden cost, a classic trade-off that every single developer needs to understand.
So here's the trade-off. Indexes make your select queries lightning fast. But, and this is a big but, they actually slow down your write operations, like insert and update. And why is that? Well, because every time you change data in the table, the database has to do all this extra work of updating every single index to keep it sorted and accurate. And just to put that into perspective for you, imagine you have a table with 5 indexes. If you add just one new row of data, that's not one write operation. It's actually 6 separate write operations, one for the table itself, and then one for each of those 5 indexes. You can see how that adds up really, really quickly.
So, this whole trade-off means we can't just slap an index on everything and call it a day. We need a strategy, a smart playbook for deciding exactly when and where to use them to get the maximum benefit without killing our write performance. So when should you add an index? Well, the playbook is pretty clear. First, focus on columns you use all the time to filter data, in your where clauses, or columns you use to join tables together. Second, if you're often sorting by a specific column with order by, that's another great candidate. And finally, a pro tip, prioritize columns with high cardinality. That just means they have lots of unique values, like an email address, because an index there is way more effective at narrowing down the search.
Now, here's the thing. Even with the perfect index, you can still make mistakes that make it totally useless. So let's look at a really common trap, applying functions directly to your indexed columns in a query.
Take a look at this example on the left. By wrapping that indexed order date column inside a date function, you completely blind the database. It can no longer use the index. The fix, as you can see on the right, is to rewrite the query to keep the column pure.
Instead of applying a function to your column, you compare it to a range of values. This lets the database do an efficient range scan on the index. So much better. Okay, here's another classic culprit that can absolutely wreck your query performance. This one has to do with how you search for text using the like operator.
Remember how we said an index is sorted like a phone book? Well, it's easy to look up Smith, right? But you can't really look up every name that ends with Smith. On the left, that's exactly what happens when you use a leading wildcard, that % at the beginning. It makes it impossible for the database to use the index, and boom, you're right back to a full table scan. The efficient way, on the right, is to only use those trailing wildcards when you can.
All right, and to wrap up our investigation, let's talk about 2 more key mistakes to avoid. First, stop using select star. Just stop. Only request the columns you actually need. This simple change can enable something called a covering index, which is pretty much the fastest way to get your data. And second, and this is a big one, don't over-index. Resist that urge to just index every column just in case. You'll waste a ton of space and seriously slow down all your write operations. Be selective.
So you've got the full detective kit now. You have the explain command to find the culprit, you've got indexes to speed things up, and you've got the playbook of anti-patterns to avoid. The only question left is, what's that one slow query mystery in your own application that you're going to go solve first?